Alright, so this is a problem on vectors. So this is from a Cambridge exam in 2008. If you don't throw food on the floor, please. Okay, it says the diagram shows a semicircular prism with a horizontal rectangular base ABCD. The vertical ends AED and BFC are semicircles with a radius of 6. So that means that O is any place or any distance from O to any point on the circle is going to have a distance of 6. It says the length of the prism is 20 centimeters. Okay, so we can see that marked for DC. And the midpoint of AD is the origin, O. Okay, so this would help if we're doing position vectors. The midpoint of BC is M, and the midpoint of DC is N. The points E and F are the highest points on the semicircular ends of the prism. And the point P lies on EF such that EP is 8 centimeters. Okay, so really, since E and F are the highest points, that means that this line, EF and DC are the same length, and you know, there's some parallelness going on if we want to draw a line through OM. Okay, like if we're going to do this. Okay, oops, okay, maybe we should use a line tool. How's that? That'll make it a little better. Oh, not that one. Thanks. Let me try this again. Technical difficulty, I suppose. Okay, so that means that OM is the same. So here's what I am going to do. Oh, and then also, just really quick, and I know this is kind of a minor point, but notice that this distance is 20. That means that P is not the midpoint, that we are going to have another midpoint, and there's going to be a distance of 2 if we're going to be using this at all. So just a little, you know, be careful of that. So we're going to use unit vectors I, J, and K, and they're parallel to OD, OM, and OE respectively, and we're going to express vectors PA and PN in terms of I, J, and K. So we are going to say PA, vector PA, and I'm just going to kind of go with the pathway. So I'm going to start here. I'm trying to go from P to A. So there's a lot of ways that I could do this. The first thing I'm going to do is I'm actually going to do my pathway indifferent. So I'm going to go from P to E. Okay, so that's that move. Okay, then I'm going to go from E all the way down to O. And then I'm going to travel from O to A. And that's my pathway. So basically, if we kind of look at our directionality, we're heading this way, then we're heading this way, and then we're heading this way, which is the exact opposite of all of our vectors. So basically, if I were to write this, we end up with PE plus EO plus OA. Okay? The problem is, since we're backwards, we need to change the direction, and we do that with vectors by just changing the sign. So, like that. Okay, now what we're going to do is we're going to go ahead and substitute distances, okay, and directionality here, so in terms of our using our vectors. So we're basically going to end up with -8, because that's the distance from P to E. And the vector associated going this way, which we're kind of for the opposite direction, is J. That's this one. So we're going to say -8J minus OE. So again, this is a radius, so it's 6. Okay, and its vector is K minus AO. Again, it's a radius, so 6. And we're heading on the I pathway. Okay. So PA, vector PA, is equal to negative 6I minus 6K minus 8J. And since these are vectors, we must put tildes underneath for it to be correct. Okay, so that is for PA. Alright, now I'm going to go ahead and do PN. Okay, so vector PN. So here's where this 2 comes into play, because really if I'm traveling here, I'm going to go from here to here, And then I'm going to head straight down. Oops, okay, well, semi-straight down. It's really straight down if I weren't drawing it like this. Okay, and that makes a 90 degree. Okay, and then I'm going to head out of 90 this way. Okay, so I'm going to add a couple new points. I'm going to call this Y and Z just for keeping track of for myself. And you don't have to do this. I'm just being very explicit, so in case you're confused, you can see exactly what I'm doing in Y. So if you want to kind of just say, well, I know that that's the distance of 2 and it's attached to unit vector I, or vector I, that's fine. Okay, so I'm going from PY, and then from PY I'm going to YZ, okay? And then from YZ, I'm going to ZN. And if you remember the property of vectors, if you don't want to say YZ, you could say EO, right? Because they're the same. So that's fine. So P to Y is going in the right direction. So I don't need to change that sign, so I'm going to leave it like that. So I'm just going to do my sign changes. And if you want to do this all in one swift step, that's fine. I'm just, again, be very explicit here so no one gets lost. Okay, going from Y to Z, we're going in the opposite direction because K is heading upward and we're heading downwards. So we're going to change that to a negative, and then we're going to swap the letters around because that means we've accounted for the directionality change. And then going from Z to N, well, that's heading in the right direction, so we don't need to change that sign. And we don't need to change the vector. So vector Pn, okay, is equal to Py has 2 units associated with it, so 2. And then going this way is J, so 2 times vector J minus, we're heading down, which this again is that 6, because this is the radius, so 6, and then that's K, plus Z to N, also a radius, which is 6, and that's unit vector, or sorry, I keep saying unit vector, it's just a unit vector I. Okay, okay, so that means that vector Pn is equal to 6i minus 6k plus 2j. So, oops, plus, okay, so those are our two vectors for part 1. Now it says find the scalar product, okay, to calculate the angle of APN. So basically, we're going to be finding this angle here, A to P and P to N. So we can do this one of 2 ways. We can either head this way or we can head away. And since they have us going from P to A and N to P, we get the same thing, so it's fine. All right, so we're going to basically start by, I'm going to find the dot product of PA, PN, so this is the dot product of PA dot PN, and that equals, and I'm going to match the colors up, so I'm going to multiply the coefficients of unit vector I, so there's negative 6 times 6, and remember the dot product is just the sum of the products of each vector, plus negative, oops, I'm in the wrong color, negative 6 and times negative 6, okay, plus negative 8 times 2. Okay, so we end up with here is negative 36 plus 36 minus 16, which is negative 16. So that's the scalar product or the dot product. Oops, I'm having trouble with lines today. My screen's off or something. Okay, so now what I'm going to do is I'm going to find this magnitude of PA. So basically, if you remember, we say it's negative 6 squared plus negative 6 squared plus negative 8 squared. So when I do that, I end up with 36 and 36, which is 72, plus 64, so root 136, which is not perfect, so I'm going to leave it like that. Okay, and I'm going to basically do the same thing for Pn. I'm just going to do this in my head, though, to save time. So I'm going to write out the, end up with 36 plus 36, because I'm squaring 6 and 6 is 6 times 6 is 36, negative 6 times 6 is 36, plus 4. So that's root 76. Okay, so that's root 76. Okay, so basically, we end up multiplying the magnitude of vector PA times the magnitude of vector PN times the cosine of theta, which is equal to our dot product. So I'm going to write it like this, because I'm just going to do this in my head. I'm just manipulating the equation, so I end up with root 136 in the denominator times root 76, and that's going to equal angle APN. Okay, so in my calculator, I punched that in, and I've ended up with 99.1 degrees is equal to angle APN, and it does need to be exactly 99.1, otherwise you're not going to get that correct only point, the A1 point. Alright, so that is that vector problem.